Welcome to OIF booth at OFC 2022. We're just really excited to be back. As you might know, we're a member contribution-driven company. We have over 130 members that represent the entire ecosystem of the industry. And what we do is we identify needs and challenges to advance technology towards adoption. And one of the ways we do that is we validate our implementation agreements with interoperability tests, such as this. And you'll see a lot of that work here, and a lot of that technology touches just about everything on this show floor and is in every operator's network. One key trend in the industry is open networking, open optical networking, and the linchpin to open networking is interoperability. And OIF is all about interoperability. So everything we do here is to define the needs and challenges. We work on technology solutions for that, and then we develop implementation agreements that enable interoperability. And then that is the key to system vendors and operators adopting that technology in form of open networking.
Here at OFC in 2022, we have some really exciting demos, and we're really happy to be bringing them out here to you guys. So we have an outstanding demo on 400ZR, where we're really bringing the true interoperability nature of 400ZR to the market, and we're showing that it delivers on the promise. We've got our CEI 112 gig demos, where we have different companies working together, contributing components, expertise, silicon, optics, everything. And it's just a fantastic demo, but it's really showing that the 112 gig work is maturing and it's ready to be published. We have our co-packaging demo, and this is really taking the show by storm because we're demonstrating that the industry is ready to do it. The technologies are coming together, the members have brought solutions. We've got optical, we've got external lasers, we've got a mock-up of the whole thing. Wait till you see it, it's really exciting. We've got the FlexE demo, where we're showing the capabilities that can be brought to do bonding, subrating, channelization of Ethernet signals. We've got the new CMIS track, and this is really bringing a lot of interest in from the visitors here at the show, because everybody wants to understand how this is going to impact their host software, how this is going to impact the modules, how it delivers new flexibility to the technology. So get ready for the tour. It's really going to be good. We got some good stuff this year.
I'm Carl Gass. I'm the OIF Physical and Link Layer Working Group Vice Chair for Optical Projects. I'm going to try to make 3 points about 400ZR today. First point is interoperability. That was what we advertised from the beginning. Second point is that we are module form factor agnostic. I'm going to show you we have multiple different module form factors in this demo. Third point is we've built an ecosystem. I have modules from multiple different vendors. I have routers from multiple vendors. I've got open line systems from multiple vendors. I've got test equipment that supports this ecosystem. The point here I'm trying to make is 400ZR is here today.
Welcome to the OIF co-packaging demo. We started this thing about 2 years ago when we worked with end customers. They gave us their application requirements about solving the problem of too much heat for the next generation Ethernet switches. We worked with them to come up with the requirements, and the ecosystem members then worked together to produce solutions to this problem. What you see here is a co-packaged Ethernet switch. You'll see here a large area with the switch chip in the middle and optical engines surrounding it. And in the front, we have external laser sources that have blind mate connectors. So that makes it eye safe with the high powers that are involved. And here what I want to show you is the ELSFP demos. This is external laser source in a small form factor. What we have over here and over here are two demos that are showing the ELSFP in action. Over here, what we're demoing is the blind mate connector. This is something that's new. And there's such high power of these lasers that you have to be careful about the loss that's in the blind mate connectors.
We are excited to bring live interoperability demos of the CEI reaches LR, MR, VSR, and linear to the show floor. These demos include multi-vendor silicon interoperability, communicating over multi-vendor interconnect interoperability, which includes copper cabling, mated test fixtures, and tuned loss trace boards. We also have the opportunity to showcase test and measurement equipment that is crucial to bringing up a CEI link. These include FEC analysis capable BERTs and high bandwidth oscilloscopes. All of these links are achieving great BER while meeting or exceeding the target loss requirements of each CEI spec. We just want to let the world know that we are also we're rolling up our sleeves and working on a 224 gig CEI white paper, and you can check that out online. Thank you.
Welcome to the CMIS demonstration. CMIS stands for Common Management Interface Specification, and CMIS is becoming the management interface of choice for sort of next generation pluggable optical modules. As CMIS is real, it's here today. It's been widely deployed throughout the industry for the past 2 years. If you look around the show floor this week, you'll see CMIS in pretty much every 400 gig and 800 gig demo. The work on CMIS actually started in the QSFP-DD MSA probably about 4 years ago, really to support the introduction of 400 gigabit Ethernet and the associated QSFP-DD and OSFP modules into the industry.
So CMIS is already in the industry. It's well deployed. It's being used on many modules in the field today. CMIS continues to evolve. We are updating the spec all the time to meet the new needs of new services. If you want to be involved, please join us in the OIF. We meet regularly to work on CMIS and update the spec.
Today we're demoing FlexE Ethernet, which is a technology that augments standard Ethernet to give it some features that extend its features and reach. So standard Ethernet has a MAC and a PCS, and FlexE is a shim layer that shims between them. And that shim layer allows us to do many things. It allows us to bond together multiple Ethernet PHYs to get rates that aren't currently standardized by Ethernet, both faster and slower. It allows us to subrate those links to match things like transport links. So if you have long haul transport that you're trading off distance for rate, say you have a 350 gigabit per second link, we can create a 350 gigabit per second MAC and match that perfectly. So there's no packet behavior in the transport queue. And the third thing we can do, and that's what we're going to demo today, is channelization. And channelization allows us to break up the standard Ethernet into pieces of 5 gigabit per second and use those to transmit other Ethernets over it.